Okay guys, today we're going to talk a little bit about parabolas. So very first thing we need is just a definition of what a parabola is. So this is the set of all points equidistant from a fixed point called a focus and a fixed line called the directrix. Now something you guys know about parabolas already probably is that when we do x squared we get the shape of a parabola. But we're going to get a little more into the geometric concepts of what makes something a parabola today. And we're also going to look at the equations as well, but the equations, not just x squared, and transformations to that. We're going to look at where the vertex is, where the focus is, where the directrix is, and because of those, what is the equation of a parabola. So very first thing here, I've got a focus and a directrix drawn in. If we use this definition, we should be able to come up with where to put the points to create this parabola. So I'm going to do a little bit of crude measuring here, and I've just got a couple markers that we're going to use for length, and we're going to see if we can find some points that should be on here. Now, looking at that definition, if it's all of the points that are the same distance away from this point as they are from that line, one point would go halfway between the two. Now, that point that's halfway between the two is kind of an important point. That's the point that we call the vertex. That should be a term that you're already a little bit familiar with. That's right where a parabola changes directions. So that's going to be our vertex right there. Now to get another point on this parabola, I'm going to use this to measure the same distance away from the focus as I am from the directrix. So basically here's what I'm going to do. I'm going to go from the focus, from the directrix. If I go the same distance from both, that puts me right about here. So there's another point on this. And if I do the same thing down here, go the same distance from the focus as I am from the directrix, that gives me another point on this parabola right about here. Alright, I'm going to do another one here. I got some different lengths. So we're going to use these two that are the same length. And so if I go same distance from the focus as I am from the directrix here, this is going to give me a couple more points that have to be on there. So focus, directrix, right about there looks pretty good. And so we're going to have a point right about here on the parabola. And then do the same thing down here. Same distance from the focus as I am from the directrix. If I make those distances equal, that puts another point right about here on the parabola. And so we can kind of start to see the shape of this parabola take form here. And we could make, do you notice this is the set of all points? So if I started making every single point that was the same distance from that line as it was from that point, what we would get is that instead of just having some dots, we'd have this entire curve that goes through all these points. So there's how we create a parabola. Now, some important points on this parabola. If we go straight up and straight down from the focus in this particular case, so basically we want to go perpendicular to what's called the axis of symmetry. Do you notice every parabola is going to have a line of symmetry that goes through the vertex and the focus? It's going to split the parabola exactly in half. This line that goes perpendicular to this is what we're going to call the lattice rectum. And you guys get your chuckles out now, it's called the rectum. But that prefix actually just means at a right angle. And that's why it's called that, like a rectangle is the same prefix. It's a Latin word base that means at a right angle. And so if you notice, this is at a right angle to the vertex and focus, to the axis of symmetry that goes through the vertex and focus. That's why it's called the lattice rectum. Now, another thing that we need to define is a length in this picture, because this is going to come up in the equations. The distance from the vertex to focus right here, we're going to call that length the variable a. Now, thinking about that, we actually should be able to come up with the length of the lattice rectum. Because if this is a, let's think about our definition right up here again. All the points the same distance from the focus as they are from the directrix. If that length is a, do you notice this length right here would also be a? Now, if we think about what we did with this length, just go straight down. Isn't this also a plus a, or 2a right there? Now, if the definition of a parabola is all the points that are the same distance from the directrix and the focus at the same time, if this is 2a, then that is also 2a. So 2a goes from here to here, and then 2a goes from there to there. And so if that's the case, the total length of the latus rectum would be, over here, 4a. So whatever a is, 4a is the total length of the latus rectum. Basically, we've got 2a on each side of the focus. And we'll do an example in a little while where we try to do this with some actual numbers to get that in there. So what are the equations of a parabola? Well, that actually depends on which way the parabola opens. And so I've got a couple different equations up here, and really these two equations are just different ones we use depending on if the parabola is opening either up or down or left or right. And so I'm going to pull something up right up here that could help with this. This is just a graph of a parabola. Now, if we look at this parabola, this is probably one you guys are familiar with. This is just y equals x squared. And if you look over here, that's just the graph of y equals x squared. Do you notice this graph opens up? Since x is squared, this graph opens up. That means for the equations of a parabola, if you have one like this where the x is squared, this is going to either open up or down. Now, from what we know about transformations, to make it open down, really what we need to do is throw a negative in there. And the place that we'll put the negative is right here on this term. So basically a is going to be a negative number to make it open down rather than open up. And then if we want to make it open left or right, we need the y to be squared. And so if y is squared, this opens either left or right. And again, whether it's left or right depends on whether the a is positive or negative. So if we put a negative in for a, this is going to open to the left. Put in a positive for a, it's going to open to the right. All right, so there's kind of our big thing that we're using for these. And you notice the h's and k's in here. H is always with the x, k is always with the y. This tells us where the vertex of the parabola is. And so for both of these, the vertex is at the point hk. So whatever this number is, now keep in mind it's minus in our standard equation here. So if this said x minus 2, the x coordinate of the vertex would be positive 2. If this said y plus 3, then the y coordinate of the vertex would be negative 3. All right, everyone okay with those ideas? All right, there's a big idea so far, and that's kind of the big thing we're going to be using is these equations right here, because from here on, we're going to try to do a couple examples that have to do with this stuff. So first off, what I want to try to do is graph one of these. So if we look over here, we have y plus 2, the quantity squared, equals 8 times x minus 1. All right, so a couple things we have to take into account. First off, we have to think, what is squared? And so you notice on this one, the y is squared. And looking at the equations we just got a minute ago, if y is squared, this thing has to either open up or down. Or, sorry, either has to open left or right, my bad. And so this one's going to open left or right. Now, the way we figure out whether it's left or right is dependent on what a is. Now, what I want us to notice is this part right here is the 4a. And so in this case, we've got 4a is 8, which just doing a little bit of algebra here, if I divide both sides by 4, that really means a is 2. And a is a positive number. That's the big thing here. A being a positive number means this thing opens to the right. So we know we've got a parabola that's opening to the right because the y is squared, left or right, the a is positive, so right. So let's put in the vertex. Now notice this is always h with the x, k with the y, and so I have x minus h. So that means the vertex of this one is going to be positive 1. Remember, it's minus in the standard equation, so it's kind of the opposite. Y plus 2, that's going to be negative 2. So our vertex here is the point 1, negative 2. All right. Now, if a is 2, keep in mind what a represented. A represents the distance from the vertex to the focus. And so you probably noticed on our original definition that a parabola always opens around the focus and away from the directrix. So if a parabola always opens around the focus and away from the directrix, and this one opens to the right, I need to go to the right 2 units from there. 1, 2. Or you could think of it, since A is 2, I need to go in the positive direction too to get from the vertex to the focus. And so right here is my vertex. Right here I'm going to put a little F for focus. Now if that's the focus, the directrix needs to be the exact opposite direction, but since the definition of a parabola is all the points the same distance from the focus as they are from the directrix, if I went 2 to get to the focus, I have to go 2 the opposite direction to get to the directrix. Now keep in mind, the directrix, this is a really common mistake, is not that point. The directrix is a line. This entire vertical line, which would be the vertical line x equals -1, is the directrix. So remember, directrix not a point, it's a line, because our definition was all the points the same distance from that point as they are from this line. And now to draw this a little bit more accurately, so we know it kind of looks like this. There's our vertex, that's where it turns directions kind of. But we don't know how wide to make it really. That's where the latus rectum piece comes in. So remember, the length of the latus rectum is 4a. Now that works out kind of handy with the equation, because isn't that number always just what's right here? And so the length of the latus rectum is 4a, which is 8. Now remember, that distance is the whole thing. So if 4a, or the whole latus rectum, is 8, that basically means from the focus, I need to go up 4 and down 4. And so that's what I'm going to do from here. I'm going to go up 1, 2, 3, 4. There's one end of this parabola. I'm going to go 1, 2, 3, 4. There's the other point on this parabola. And so to draw the parabola in, I'm going to make sure we hit that vertex, hit both of these endpoints of the latus rectum, and there's our parabola. Right. Is that making sense how we came up with that? All right, so we got 2 there, 2 there, because A was 2. Whole distance of the latus rectum is 4a, so that's 8 total. So we went 4 up, 4 down from there. All right, let's try one the other direction. So the next one, we're going to try to find the equation of a parabola. Now this one's a little different. If you notice, I put a picture here, but the picture is not actually given. This is strictly for reference, so we actually don't need to graph this. What we need is the equation in the end. But I'm going to do a little bit with this drawing just to help us figure out what the equation should look like. So we've got a vertex at 0, 4. We've got a focus at 0, 1. And that's basically all we know here. So I'm going to plot those points. We've got 0, 4. That's our vertex. We've got 0, 1. That's our focus. Now, from what we've seen already, every parabola opens around the focus and away from the directrix. So if this parabola has to hit the vertex and turn direction there and open around the focus, this has to open down. So we know this is a parabola that opens down. And so we know it looks like this. The x has to be the squared term. So we know this has to look something like that. Now we just kind of have to fill in the numbers. Remember, the vertex is hk. So that kind of gives us that. And remember, A represents the distance from vertex to focus. Now, if we want to go from vertex to focus here, we went 3 units. But the thing to keep in mind is we went 3 units down, which means this distance right here for A is -3. So now I'm just going to put all the information that we have in here and see if we can come up with the equation. So we have x minus h. Well, h is 0, so it's x minus 0, the quantity squared, equals 4a. We just found out a was -3, so I'm going to put that in there, times y minus k. K is 4, so we've got y minus 4. All right, I'm just going to do a little bit of simplifying here. If it's x minus 0, we really don't have to write that. Minus 0 doesn't do anything. And so I'm just going to call this side x squared. And then we've got 4 times -3, so that's a -12 there. And then times y minus 4. So there is the equation of a parabola that has a vertex at 0, 4 and has a focus at 0, 1. We knew it opened down, therefore the x has to be squared. And from that, we actually know it has to be a has to be negative, but distance from vertex to focus was 3, so going down 3, negative 3, and so we plug that in for a, plug in our vertex for h and k, and that's our equation. All right, this should get you a good start on parabolas. More to come on parabolas. We'll actually have one more day of talking about parabolas and finding some more information about that. So that'll wrap it up for today and give you enough to do your first assignment.